All right, energy bar charts. This is a way in which we are going to quantify and represent energy storage and energy transfer in a visual representation. So on your document, you should see at the very top, you should see an example of hot cocoa. So let's consider the example of hot cocoa and taking that hot cocoa and putting it out on a counter. And we're going to leave it set for about an hour. For energy bar charts, we want to depict what is the initial energy, what is happening to that energy, and then what is our final energy. Okay? So first, we want to define the system. The circle represents the definition of the system. What is the system that we are working with here? Well, we're working with hot cocoa. So in the circle, we need to write hot cocoa. So we're going to keep it simple and clear. We aren't going to write a whole sentence. We are just simply going to say that our system is hot cocoa. All right, next step. We need to decide how energy is involved initially. We know that hot cocoa is initially a pretty hot liquid. We have done particle models to represent solids, liquids, and gases. We know that liquids are kind of the middle amount of energy between a solid and a gas. So that tells us that a liquid has more energy than a solid, but less energy than a gas. We need to determine the initial thermal energy. We use ETH to represent thermal energy. There's a whole bunch of different types of energy. E stands for energy. The TH in the bottom right-hand corner stands for the fact that it's thermal energy. It's heat energy. So the more particles that move, the greater the temperature, and therefore the greater the thermal energy. We've got a couple of diagrams here, particle models here, that are showing that if we have a solid and it is cold, those particles aren't spread out very much, whereas if it is hot, those particles are spread out more. Same thing with a liquid. A cooler liquid, the particles are closer together. If it's a hot liquid, the particles are spread further apart. So we want to quantify thermal energy. To quantify the internal particle energy, the thermal energy, we'll use different size bars to go with each phase. A solid has less energy, so we're going to have a smaller bar. A liquid has a little bit more energy, so we're going to have a little bit higher of a bar. A gas has the most energy, so we will have the largest bar. So let's go back to our bar chart. And we said that the hot cocoa is initially hot. It's not a gas, it's a liquid. Liquids are in the middle with the amount of energy. And so we are going to put a bar somewhere slightly towards the high end of middle, meaning that it's a hot liquid. What is happening to that hot cocoa as it sits out on the counter for an hour? Jace? It's cooling. So is energy entering the hot cocoa or leaving the hot cocoa? It's leaving. So if energy is leaving the system, we are going to put an arrow on hot cocoa pointing outward. This tells us that energy is leaving the hot cocoa. If energy is leaving the hot cocoa, is our next bar for final going to be higher or is it going to be lower? Mr. Titus? It's going to be slightly lower. So we put an arrow saying the energy is leaving, and our next bar is going to be a little bit lower because some of the energy that was in the hot cocoa is leaving. Where does some of that energy go to? Hot cocoa sitting on the counter. Over time, where is the energy going to? Mr. Jace? Yeah, some of it's going to go to the air. Where is some more of that energy going to go? Mr. Lucas, where else will we end up with it going? Maybe some of it's just going to extend out of that hot cocoa into the cup itself before it then dissipates into the air or is transferred into the air. If I pick up that cup and I put my hand on the counter, what am I going to notice? Oh, the counter's a little bit warm, meaning that some of that energy went where? Oh, into the counter itself. So energy is leaving the hot cocoa and it's going someplace else. Okay? We are going to try other examples in the energy bar chart assignment. We're going to hold on until tomorrow to do so. But one note that we need to have, the quantitative amount is open for interpretation. For example, how small that you have that initial or final bar is kind of up to you. We know that gases are the highest, liquids are middle, solids are low. So in this case, I would interpret the temperature to decrease, and I am kind of open to where the bar is going to be. It's my own interpretation. What I'm looking for as your teacher is, are you showing the energy is gained or are you showing the energy is lost? Okay? As long as you're not showing too much energy loss or gain, we're going to be good. Okay? You do not.